Okay, today we're going to be doing number of islands. Given an m by n 2D binary grid called grid, which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So let's go to the examples here. In example 1, you can see that we have a grid which contains a singular island. The singular island is going to be this grouping of ones, just like so. And there are no other groupings of one. And then in example 2, we have 3 islands. Those 3 islands are going to be these 4. Then you have a small island right here. And in the lower right-hand corner, you've got 2 ones. And this is how you've got 3 islands in example 2. So how could we write some code that would be able to find the islands on a grid? Well, let's head on over to the blackboard to find out. How are we going to solve the number of islands? Simply looking at the grid, it's pretty easy using visual cues to see how many islands there are. Almost immediately, we can see that in this grid, we have 2 islands. The first island being the groups of ones here in the top left corner, as well as the ones here in the lower right-hand corner. But of course, we want to solve this programmatically. And so how are we going to do that? Well, we would want to use something like a search algorithm. In this case, let's go with a depth first search. And the general strategy here is we're going to be starting in the top left corner at position 0, 0, and we're going to be searching from the top left corner to the bottom right corner for all of the islands. So the first thing we would do is we come here at 0, 0, and we would say, are you a piece of land? And of course, here in this case, the answer is yes. We have a 1. We are a piece of land. So what are we going to do? Well, we know that we have the beginnings of an island. We need to see how big it is. So we need to now look to the right. We need to now look below, to the left, and above to see if we have other pieces of land. So in a depth first search, let's say the first direction that we're going to be looking is the right. So we would hop on one column to the right and say, hey, are you a piece of land? And we say, yes, yes, we are. So we mark that piece of land also as visited. And we continue moving over column after column after column saying, are you a piece of land? Yes, you are a piece of land. If you are a piece of land, we mark you as visited. And then we continue on. When we get to here and we look at the next one, we say, oh no, you are not a piece of land. You are water. And so now what we have to do is we have to look in a different direction. In this case, we are currently at this one right here. So maybe the next thing that we do is we look down, say, no, you're a piece, you are water. Then we might look to the left. You say, no, you are already visited. And then we might look above and say, no, you're actually off of the grid. Once you are done looking at all of the directions at the current deepest element that we are looking at, you would then pop back to the previous element and continue looking in all directions. So when you go back here, you'd say, okay, now that I am on this guy right here, maybe I'll look down and say, oh, yes, I'm a piece of land. So then we will be here. And once we are here, you're going to continue doing the same depth first search. Eventually, there are no more pieces of land to find. And so you have completed your search of the current island, just like so. You pop that back and you increase your count of islands by 1. Then what you do is you continue moving along the grid and you continue this process when you get here. Eventually you find this piece of land, you gather it up and you find your new island here, and you continue counting, looking through your grid. You view this guy as visited, you go here, bop, 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 also visited, and eventually you pop out beyond the last row and you say, okay, I am now looking at the next row, but the next row is outside of the grid. So we are done searching for our islands. Let's take our count of islands and pop that back as our answer. So let's get on to the actual solution inside the Clojure code. So how are we going to solve this? The number of islands. Let's take a look at the main function and build out any helper functions as we go along. Well, we know that we're going to have to loop through the entire grid of all islands. So let's go ahead and make a loop. And the things that we're going to loop through, we're going to loop through the rows, which are going to start at 0. We're going to loop through the columns, which are going to start at 0. We're going to go through the grid, which is going to be our grid. And as we are going along, we are going to be counting the number of islands. So we can do number of islands, and that's also going to start at 0. While we are looping through, there's going to be different conditions. The conditions which we are going to have to keep track of are going to be 1, our return case. We are past the final row. And if we are past the final row, we want to return num islands. There's the case that we are at the end of a column and we need to go to the next row. We are at the end of a column, next row. There's going to be the case where we find an island and we will need to search island and update grid. So where we find an island and then we need to go and search to see how big the island is. And each part of that island needs to be marked as visited so that it doesn't get double counted. And then finally, there's the case where we need to continue searching through the grid, move to the next column, right? So those are our 4 conditions. Let's start working them out. So we are past the final row. We are going to say this is going to be greater than or equal to current row, the rows in the grid, and we need a way of figuring out how many rows are in our grid. So let's go ahead and make a helper function to do that. Rows, this is going to be taking a grid. What we want to return here is the number of rows in the grid. That's going to be the number of elements in the outer vector. So let's see how that could look. And the count of I1 is 4. Yeah. So if we just count the number of elements inside of I1, that's 4. And that would be the 3 vectors of ABC. And so that is indeed our number of rows. So here we will return a count of grid. And so if we do from here, instead of that, we can do rows of I1. We also should get 4. Yeah, good. So we have our rows. The next thing that we want to do is we want to get the number of columns. That's going to be the next condition that we're going to be concerned about. And that's going to be the number of elements in a single row. So we could do a count of the first element of I1. And that is 3, and that's going to be those 3 ABC. So that is the number of columns that we have. So we can do cols. This is also going to be a grid, and that's going to be a count of the first of the grid. And so if we go here and we say cols of I1, we should also get 3. Good. So now we have the number of columns. So if we are in the case that we're past all of the rows, what we want to do is we want to return the number of islands. Else if we are at the end of a column, then we want to do a recur and we want to do a new row. So that's going to be a new row. And we're going to start at column 0. We have no update to the number of islands, and we have no update to the grid. And we can go ahead and put this in a let binding, and we do row is going to be next row, and column is going to be 0. The next one that we can do is let's do our default case and do the search last. The continue searching through the grid, go to the next column. We will want to be doing current row. It's going to be the next column. We have no new islands, so we have num islands and we have the same grid. And we can go and put this in a let binding where column here is going to be the next column. And so now I think we've got all the cases except for the case where we want to be searching our island. How is that going to look? This is going to say island. Oh no, this is not island. This is just to say, are we looking at land given the current grid and the current row and the current column? And in the case that we have land, we are going to want to update our grid, visit that island, and increase the count of our islands And finally, we will want to move on to the next column as we're going along the current row. So we will be in the current row. We will want to move on to the next column. We will want to have an increase to the number of islands, and we are going to have our updated grid. So column here is going to be the next column. Num islands is going to be an increase to the num islands. And our grid is going to be our searched island. And we're going to be using depth first search. So we'll do a depth first search on our grid with the given row and the given column, okay? But now we've got two functions here which we don't have defined. So let's go and get those guys defined. So we have land. And land is going to be taking a grid, a row, and a column. And this is going to check to see if we have the value 1 there, right? So we have 1, and we are going to be getting the value from the grid at the row and the column at that point. So if we go and we check this, so we've got an island here filled with 1s and 0s. If I do land of I2 at 0, 0, that should be land. In the next column, that should not be land. In the next column, that should not be land. And if we are off the board, that is also not land. If we do 2, 2, that is land. If we go off the board, that is not land. If we go off the board in terms of rows, that is also not land. So land is working. So we have our land. And finally, what we need to do is we need to have our search. So let's go and start making our search. Depth first search. This is going to be taking a grid, a row, and a column. And what does our depth first search want to do? Well, we need to search it if we have a land, right? So if we are land, grid, row, column, then we want to perform search. Otherwise, we want to return the grid. Let's make another function here. Visit island. Visit island. Yeah, we're going to visit the island here, and we're going to pass into this. Yeah, we're going to have to recursively do our DFS here. We're going to give it the grid, we're going to give it the row, and we're going to give it the column. And this is going to be our search function. Let's call this DFS grid, row, col. And what are we going to do here? We are going to be using, in this case, a reduce function in order to do this. So we would say reduce, and reduce is going to take some function, some start, and some iteration, right? If we look at reduce, we say a function comes in, a collection comes in, and you also have the option to do a value. So our iteration is we want to visit in all possible directions. And so that's going to be directions. And let's go ahead and define those directions here at the top. And the directions are going to be the next column. So 0, 1, that's the next column. We can do the previous column. We can do the next row, and we can do the previous row, right? And so we have directions, and in our function, we will want to take our grid as well as a direction, and then we will do a let binding, and we'll do the direction in rows is going to be the first value of direction. And then the column is going to be the second value of direction. Yeah, so directions here is going to be passing in this. And we are going to be performing this function on each of the directions in directions. And we are going to start with this value here. The starting value is going to be turning that current grid location into an X. So we can do a soc into grid at the row and column, the value X. And the reason why we are setting it to an X is so that we no longer view as unvisited land, okay? And now that we have that let binding, we can now go and do the next grid. We are going to be able to do the DFS on our new updated grid with X's instead of 1s. And we will check we will adjust the row and we will adjust the column. Let's go ahead and do a print of this. If land, yeah, comment, and then we will say visit island of I2, and we will give it the DFS, so our DFS function. Let's go ahead and put this guy below here, I2, and then we can give it that guy, and we will go 0, 0. And here we would expect it to find this guy, and this guy. Yeah. So that looks pretty ugly. Let's go ahead and make it a little nicer. There we go. Shoop. And what do we have? So starting with this location here, we turn it to an X. And then the first thing that we do is we check the column to the right. So we check the column to the right, it doesn't do anything. Then we check the column to the left, it's off the board. We check below and it is an X. So we check to the right, it isn't anything. We check to the left, isn't anything, we check below. And then here we check to the right, it isn't anything. We check to the left, it isn't anything. We check below and we check above, and it is also already visited. So it is not land. And so here we have X'd out our island. The island has been successfully found. And again, the way that that works is we are going to be reducing. We are starting with this value, and this function here is going to take each element in directions, give us direction. From direction, we pull out the adjustment to the row, the adjustment to the column, and we perform our search on this new updated grid in each of these new directions. So that looks like it works to me, and I suppose that will do it for us actually. Let's go ahead and try this out on a set. So we can go and now do, let's get ourselves an island. Boom. Islands, I3. And there's 3 islands. 1, 2, 3. Great. So that would be correct. If we go, we put another island here, it goes up to 4. If we have a whole no islands in here, is 0. Ah, let's take it over to our test set and see how it looks. So here we are at our test set. We've got a couple of islands defined. Let's go ahead and run our tests. When we run it, you can see that with our one test, we've got 4 paths. 0 fails, 0 errors. And so pretty confident that it works. So here's the solution that we've got. You can see that at the very top, we are defining all of the directions. You've got the next column, you've got the previous column, you've got the next row, you've got the previous row. We have a helper function which says, are we currently looking at land? We know that it is land if it is a 1. So from the grid at the given row and column, do we have a 1? If it is a 1, then it is land. We have a helper function which gets our rows, which is the count of the grid. We have a helper function which gives our columns, which gives us the count of the first element of our grid. We have our visit island helper function, which is going to be taking our depth first search, and it's going to perform a reduce in all 4 directions. So starting with this case where we put an X at the given location, where the given location is indeed land. So we start marking our land with X's. And then for each direction here, we perform the following function where we have our updated grid, which is our grid with X's, and our current direction that we want to go. And what we do is we perform our search again recursively on our grid, which we are updating at the current row plus the direction row, and at our current column plus the direction column. This will then call back to our depth first search and say, are we land? If we are land, we want to be continuing to visit our island. And if there is no land to visit, we will finally return our grid. This goes to our num_islands function. The num_islands function is we are looping across the entire grid. In the case that we have exhausted every row in the grid, we are done searching the grid, so we return the number of islands. If we are at the end of a column, we then want to go to the next row and start back at the 0th column. If we found land, then what we want to do is we want to increase the number of islands. We want to update the grid with the visited grid. And finally, we want to go on to the next column. And finally, we've got our default case, which is we are on a current row. There are still columns to visit. We're just going to go to the next column and keep searching. So that's that. I hope you enjoyed this solution. If you have any better solutions, please let me know. And otherwise, we're going to see you next time. So have a great day. Bye.